Washington State University. Go Cougs!
Hello everyone. In this video, we're going to cover lesson 3 of our Working with Activity and Health Data module. We're going to cover hierarchical indexing in this lesson. So far in the course, we've been working with one-dimensional indices. For example, when working with populations for cities, we had a one-dimensional index of strings representing the names of cities. In our previous lesson, we were working with an integer index from 0 to n-1 that uniquely identified each row in a data frame. And here's an example of that data frame. We had participant ID, task, duration, age, and class. Note that these values here are from after cleaning these columns. So one thing that's important to note about this particular data frame here is perhaps an integer index from 0 to n-1 is not the best way to represent this data. For example, a participant ID and a task together uniquely map to a duration representing the performance of this participant on this task and how long it took them. However, simply the participant ID is enough to uniquely identify their age and their class. So what we have here is a natural hierarchical index that can be used in order to reduce redundant information in this data frame and can also make working with the data much easier. So let's take a look at how this hierarchical index looks pictorially. So at the top, our outermost index, we have participant ID, PID. So PID can uniquely identify age and class, but PID cannot uniquely identify a duration. PID indexed with an inner index, task, can identify a duration. So what this leads to is two different options for how we could store this data alternatively using hierarchical indices. So our first option would be we still have one data structure. It's a data frame with a hierarchical index such that our outer index is our participant ID and our inner index is a task, and columns, duration, age, and class. However, we're going to have redundant copies of age and class for each task, just like we do up here. Our second option is with two data structures. We have one data frame with an index, which is our participant ID, and columns, age, and class. So this is a one-dimensional index. In this case, we won't have any redundant information. We're only going to store the age and class once. So the number of rows in this data frame will be the length of the number of participants in the study or in the data frame. The second data structure would be a series with a hierarchical index, just like our previous hierarchical index, outer participant ID, inner task, and the value that a participant ID and a task together would map to would be a duration. So I've shown this diagram here to help make a little bit more sense of this second approach. So here, the green is our data frame with participant ID as the index, which can uniquely identify our age and our class columns in the data frame. The blue circle here represents our series where we have a hierarchical index, a participant ID, indexed with a task ID can uniquely identify a duration value. So there are different trade-offs to each one of these approaches, and if we consider our original storage approach with a unidimensional index, we have three different options. For this class, we're going to use option number 1 because it's easier to keep track of one object instead of two objects. But for practice, I recommend trying to implement option 2. It's a good exercise in pandas, and it also saves on space. Now let's take a look at an example that I adapted from the Pandas documentation. Here's the link to the original source code here. So in this example, we have two parallel arrays. Here's the first one, which represents our outer index. Here's our second one, which represents our inner index. A combination of a value in the outer index and the inner index can uniquely identify, say, a value in a series or a row in a data frame. So the first thing we're going to do with this data is we're going to create a list of pairs of our outer index to our inner index, our outer index to our inner index. We'll store this in tuples. Let's take a look at what tuples looks like. So here's tuples. It's a one-dimensional list of pairs where each pair is a two-item tuple. So essentially we're zipping together these two arrays here. So bar pairs with 1, bar pairs with 2, baz pairs with 1, etc. Now the next thing we're going to do is construct a multi-index object from these tuples. And we're going to name the first item in each tuple as belonging to a list called first, and the second item in each tuple corresponding to a list called second. So essentially the name of our outer index is first, and the name of our inner index is second. And if we print out this index, we see a multi-index object here. Here are our levels, here are our identifiers, here are our labels, and the names are first and second. So now we need to use this multi-index with some data. So here, Pandas series is constructed from 8 random values. The index is set to be our multi-index here. And the name of this series is random data. So the reason why there is 8 values here is because there's 1, 2, 3, 4, 5, 6, 7, 8 values in our hierarchical index, or pairs in our hierarchical index. So if we print this out, here is the series that we see. So here's our outer index first, bar, baz, foo, clue. Second, 1, 2, 1, 2, 1, 2, 1, 2. And here are our 8 random values. So if we need to index into our series, we can do so by indexing once into the outer index, which is called first. So here is a value in our outer index, bar. So if we index once to get bar, we get the series 1, 2, which are these two values here. Now this has a unidimensional index containing 1 and 2. If we index twice, bar and then 1, then we essentially will get the value uniquely identified by bar and 1, which is 0.24, which we see here. One thing that is useful to point out is we can create a multi-index using readCSV and toCSV. So let's write this multi-indexed series out to a file. Then we're going to read in from the file, and we're going to see that it's quite easy to set the hierarchical index using our index call keyword in toCSV. So let's go ahead and write S to CSV. We'll write it to fname. Okay. Then we're going to immediately read it back in. This time we'll call it S2. So S2 gets pd.readCSV, and we'll read right in from fname where we just wrote this out to file. And we'll set the header to be none. There is no header. And we'll set index column to be 0 and 1. So let's run this, and then let's go take a look at that file. So this was called hierarchical foobar.csv, and here it is. So there's no header here, and our two index columns essentially just look like columns in our CSV file. Okay, so now let's go ahead and print out S2, see what it looks like. Okay, so here we have these default labels assigned to each one of our outer and inner indices, and also for this column. And note, this is a data frame at this point. So let's do a little bit of work to rename these indices and also to convert this into a series. So first, let's set index names to be first and second, and we'll do this in place. We could avoid having to do this if we wrote out the names of these indices when we wrote to a CSV file. Next, let's rename column 2 to be random data. And let's also do this in place. Now let's print out S2 shape and print out S2 again, and we can see how it changed. Okay, so now we have first, second, and we have random data. So the last thing that we're going to want to do is convert this to be a series instead of a data frame. So let's just index into S2 at random data, and then we can print out the type of S2. And there we see it's a series. So the last thing that I want to show is how we can read in our clean data frame from our Parkinson's disease healthy older adults activity data set straight into a hierarchical indexing. So let's have df is assigned pd.read.csv. We'll read fname, header row is 0, and index columns will be 0 and 1. So let's go ahead and print out df. And there we see a hierarchical index applied to our data frame. So we don't have PID repeated for each one. PID 0 will index into this subset of the data, and PID 0 and task say cook will index into this data set, this subset of the data set. But you do still see that we do have age and class repeated, and that is because we have chosen to use data storage option number 1, where we have one data structure instead of 2. But we could eliminate this redundancy with data storage option number 2. Now, I'm not going to go over how we could construct a hierarchical index such as this once we've already read in the data, but I will include it in the notes if you're interested.